So in this section, we're going to move away from linear inequalities, that's inequalities that make a line when graphed, into quadratic inequalities, ones that make a parabola when graphed. We're going to start out in this section with dealing with one variable, just x's, and in the next section we'll go to two variables and deal with the graphs there. So to solve x squared minus 2x minus 3 is less than or equal to 0, we need to actually change it a little bit. We need to go back to the quadratic equation, changing that less than or equal to sign into just an equal to sign, and solve that equation first, and use that as a basis for something called a sign analysis, which we'll get into afterwards. So the easiest way to solve this is factoring if we can. We would need two numbers that both multiply to -3 and also add to -2. -3 and 1 will work, so this would factor into x minus 3 and x plus 1 equals 0. Take that, split it, so that we have x minus 3 equals 0 and x plus 1 equals 0. Solving for x on both of those equations, we have x equals 3 and x equals -1. So those two values form the basis of the sign analysis. I'm just going to flip over to the next slide to do that. A sign analysis is a number line. And by sign analysis, I mean analyzing whether or not this function is positive or negative or 0. The zeros get taken care of by the solutions to the quadratic equation. Remember that they could be called solutions, they could be x-intercepts if we're graphing them. Often they're called zeros, and that's the circumstances we're going to use today. So our two values were -1 and 3. And yes, I know when I solved them, I had 3 before -1, but since we are going on a number line, we do need to go in order. So those values will make this function work out to 0. And that's divided this up into 3 separate regions. This one here, 2, and 3. And the nice thing is that in between, let's say in between -1 and 3, that middle region, the function will either be positive or negative, and it won't change. We just need to determine whether it's positive or negative. To do that, I'm going to pick on the left side first. We need to pick a number in this left region, which would be anything less than -1, -2, -3, -4. We could use decimals. I like to deal with numbers that are close, just to make the math a little less intense. So to check -2 or any number on that side, we take it, we plug it into the original expression, and we see what it works out to. So -2 squared is 4. -2 times -2 would be +4 and -3. That works out to 5. Now 5 is a positive number, so anywhere in that region, that function will be positive. Working over to the middle, we need to pick anything between -1 and 3. I'm going to pick 0. Whenever I can, I choose 0 just because it makes the math even easier still. Plug it into the function, we get 0 squared minus 2 times 0 minus 3, which would be just -3. That -3 is a negative number, so anywhere here in the middle between -1 and 3, we would have a negative. Last thing, I need to check some number on the right side, so 4, 5, 6, and so on. I'm going to pick 4, substitute that into the original function, work it out. 4 squared is 16, Negative 2 times 4 is negative 8, and minus 3. And that works out to 5, which is a positive number. We're not quite done yet, but this sign analysis now gives us the tools we need to fully answer the question. Looking back at the question, we were looking specifically at where this function is less than or equal to 0, which I'm going to add in up here. Now, less than or equal to 0, we need to determine whether that means positives or negatives. When less than 0 would be negatives, so the areas that we're looking for on the sign analysis are in between negative 1 to 3. How do we say that? Well, we can use inequalities again. The nice thing is that this is one region that is sandwiched between two numbers. So our x, whatever value, is going to be in between negative 1 and 3. X would have to be greater than negative 1, 0, 1, 2, and so on. X would also have to be less than 3, 2, 1, 0. But it also could be equal to those, because up here we had equal to, less than, or equal to 0. So that will be the giveaway for these signs, why they have the equal to's with them.